Hello, and welcome to the Argyle AI Decision Maker Summit, revolutionizing business strategy with AI. My name is Nick with Argyle, and it's great to have everyone joining us today. A couple of notes before I turn things over to our esteemed speaker. To ask questions throughout the session, simply type into the Q&A chat, and we will address your questions at the end of the session. Also, be sure to subscribe to Argyle on YouTube for exclusive access to all our past events. Now, without further delay, I would like to introduce our speaker, Alok R. Chaturvedi, PhD, Professor of Management, Purdue University. We're super excited to have Alok with us for a keynote presentation titled Agentic AI, Farce or Force for Business Success. Welcome, Alok. Over to you.
Thank you, Nick. Greetings. Welcome, everybody. And it is a pleasure for me to address you. So today I'm going to talk about agentic AI. And I've been working on a framework for over 20 years. My claim to fame or infamy was that I used this type of integration of multiple simulations in 2006 for a Department of Defense event called Urban Resolve 2015. And in that war game, so we essentially enabled tens of thousands of simulations to integrate autonomously and organically using our platform. And we call that platform Society of Simulations. Although the framework was developed 20 years ago, it has been in use ever since. And it was almost a natural way to migrate from Society of Simulations to Society of Agents. And here I'm going to share two use cases, one in healthcare and then the other one in workforce. But before we get to that, what is agentic AI? So what happens is that in traditional AI, all the queries are responded by a single AI. So if you're using ChatGPT or if you're using Claude or Gemini, so you ask a question through prompts and it is going to give you a response. So you are interacting with it. And even with more advanced features like different types of calls, different types of integration. So what you are essentially doing is you are essentially executing different procedures and stuff like that. So here it is, all the actions are essentially human triggered and there's very little autonomy. But if you're building a system on that, it is very difficult to adapt to novel scenarios. Whereas in agentic AI, so you get multiple AIs to work together. And when they're working together, so they make, each AI makes their decisions autonomously, and they adapt to the changing conditions, coordinate with other agents, and learn from each other's outcomes. So the real question is that, is agentic AI production ready? So my answer to that is it depends. So one of the biggest challenge which we are facing with agentic AI is multi-agent coordination. So most of the framework which we have is we have agent-to-agent communication. But as you increase the number of agents, then the communication among them explodes. So if you have point-to-point coordination, it creates exponential complexity. And that complexity, I mean, essentially leaves a lot of holes if you are designing different frameworks to capture a variety of communications among agents. Then there's temporal heterogeneity. So different agents are working in different timescales. So some of them may be working in seconds or even microseconds level. Then you have strategies which may unfold in months or even in years. So how do you coordinate with that? Because each one of them, they are running on different scales. And that multi-scale and that scale can be not only in temporal sense, but it also can be in location. So different agents are running on different data centers on different clouds, and then there are different, what you're going to see is different types of latency or delays. So it reminds me when I was doing simulations in DoD. So in some situations, what you're going to see is because it's all if all the processes are distributed. So sometimes it may happen that a tank will blow up, and few moments later, a missile will come and hit that space. Because the events, how you're going to coordinate the events, and how you're going to ensure that the events happen in a certain sequence. So that creates a problem. Then there's also semantic fragmentation. And so, each department in an organization speaks a different language. Although we have had some uh, reconciliation using the ERP systems, but still the semantics are very different. So even though the syntax may be similar, but the semantics are very different. So if you are trying to base all the integration through syntax, then the protocols become brittle. So if you have pre-programmed rules, and whenever you have some novel scenarios, then the older protocols, they break. And fixing those protocols, that is the challenge. And so that is what we were facing when we were doing Urban Resolve 2015, is that most of the integration was happening through syntax. And we came in with our approach of Society of Simulation, where all the integration was happening in uh, uh, in semantics. To give you an example, so let's say we are creating a situation where there's a fire in a building. So you have a building, you have stuff in the building, you have people in the building. Now, an event like open the door, it has different semantics for different models. So we have a structure model, we had a fire model, and then we have agent-based human models. So that opening the door means different things. So fire model, opening the door means there's more oxygen, and then it is going to burn faster. The structure model, because of the heat, the structure is changing, and so the structure changes. And for human, opening the door event becomes a escape route. So the same event will have to be interpreted differently, and different models are going to consume it and work it differently. So there are very similar situations here in agentic AI. So the advantage is that the agentic AI, the agent has the knowledge and wherewithal to analyze all these events. And so by properly configuring the agents in agentic AI, then you don't have to write all those hundreds of lines of code to take into account that how many events are going to take place and how those events are going to be interpreted. But that challenge still remains, that even though you can easily interpret it, but then how you're going to coordinate among the actions each of these agents are going to take. So that is where Society of Agents framework come into play. So here what we are using is a quantum inspired emergent coordination. So here we are not using quantum computers, but what we are using is quantum mathematics. So we are borrowing from that. And in management, there's a old, long tradition of borrowing from physics, like uh, in finance, Black-Scholes model for option pricing has been borrowed from physics. Game theory has been borrowed from math. For game theory has been borrowed from physics. And there are multiple instances like that. So here we are borrowing from quantum mechanics. And so here what we do is we bring in, all the agents, they have all the different events in superposition. So all the events are handled simultaneously. And then there is a shared reality, and that reality is shared by all the agents, and they are also in superposition. Now, given the situation and instance, and depending on the case, the large language model essentially measures at the time of decision making and the semantic operators then collapse the uncertainty, and you have a very specific rule that comes out of that. So you can think of it as all the rules are simultaneously being evaluated, and once the decision is made, uh, so it collapses and one rule gets selected. And so here our complexity comes down dramatically from complexity of n square, it comes down to n log m. And that is, essentially becomes linear. And the efficiency which we are seeing has improved by over 67%. And this is on the conservative side. With more tuning, we can get this number even higher. So how has agentic AI evolved? So we are seeing some rapid movement in agentic AI. And so here things have moved from 2020 to 2022. So when GPT started to come out, so starting with single LLM agent, so it was like for chatbots and task automation. And there was very limited use of tools, and there was hardly any coordination among agents. Then came 2023, and so tools using agents started to emerge. So the first to do that was LangChain, and along with that, Llama Index introduced tool to agent integration and function calling capabilities in ChatGPT 4. So that essentially allowed agents to go outside their own closed world and to interact with the outside world. So they were still isolated and there were still single agent systems. But in 2024, multi-agent system framework started to emerge. And Microsoft AutoGen, so this was a conversational multi-agent system. Then, Crew AI came up with role-based team coordination, LangGraph, so graph-based state management. And so, but still there was a framework lock-in. So if you decide on AutoGen or Crew AI or LangGraph, so then you are pretty much locked into that framework. And there was hardly any interoperability. Then in 2025, this year, we are beginning to see a lot more protocol standardization. So in November 2024, MCPR, which is the Model Context Protocol, came out. So that is where the agents could interact with the tools. So that was agent to tool communication. And Google came out with A to A, agent to agent coordination. So two bilateral coordination is supported by A to A. And so now there's a big push for a universal standard, but still it is, we are still struggling to have that. So here are some of the things which each of these, agentic framework are capable of. So AutoGen from Microsoft, so they're really good for research. So like you have research, and then you have enterprise R&D, etc. So here, if you're using that, it's a pretty steep learning curve if you're using AutoGen. In Crew AI, so that is role-based teams. So it has intuitive role definition, fast prototyping, clear task delegation, but you have much less control over the flow. So this is best for rapid development startups, so you can get going very quickly with Crew AI. LangGraph is graph-based workflow. So there you can model very precise flow control, stateful execution, and there's visual debugging tools, but the complexity overhead is high. And LangGraphs are best for complex workflows and for production. So there are the several coordination mechanisms. So you can think of it as the glue between different agents. So there are, essentially the most popular ones are MCP, which is Model Context Protocol. and this was released in November 2024 by Anthropic. So here the main purpose was to connect agents to tools and data. And so here it is one to many frameworks. So it is like a single agent that can interact with multiple tools. So you can think of it as a USB-C for AI applications. So key features here are prompts, resources, tool primitives. So it has standardized for server architecture, 1,000+ community servers, and the adoption is done by OpenAI, Zed, Triplet, and SourceGraph. Google's agent-to-agent protocol. So here it is primarily, as the name suggests, it is agent-to-agent coordination. It is more for multi-agent system interoperability, but still it is mostly bilateral. And then key features is task delegations and handoffs. So, you can do secure identity on authentication, state sharing, and context transfer. So you can do things like context chaining. So you can transfer the context under which the decisions have been made. So it gives a lot of power to the developer that, how you can share the common knowledge. And then so here it is adopted by Atlassian and Salesforce and SAP and Cohere. Then you have NA10. So that is another framework. And so this is an open source workflow automation framework. So here you can build a complex system using visual builders, and then you can essentially build workflows with multiple agents. And here, NCP servers support as tool access. So I mean, essentially what it does, it helps you generate complex workflows. And so here it allows you for multi-agent orchestration patterns. So there are some fixed patterns like gatekeepers and hierarchical. But here you have human in the loop, you have visual debugging and data, but no framework login, because you can pretty much, using this, you can put anything in the workflow. But it is limited by persistent memory. And so here you need an external database. For example, you may need some vector databases or something. And it also has token limits for complex context, because so this is more or less a trial and error where you try to figure out how many of the systems can work together. Then there is real world use cases, and then what we come to is society of agents. So here are some of the real value which society of agents brings in. So it is emergent and quantum inspired measurement, because now all the complexity is assumed by the society, and it simultaneously evaluates all the different possible paths. So like in all the other framework, the designer has to predetermine what the paths and what the communications has to be. And if there are anything new, that's where the brittleness comes from. And so here it can generate, I mean, all possible interconnections between the agents, and it is getting evaluated simultaneously. And what happens is that when an LLM essentially decides, so that is when the measurement happens and the superposition collapses. So that gives us a tremendous power. So I mean, essentially what it provides is an LLM mediated translation. So this is a dynamic semantic evolution. So it can work on multiple temporal scale and also spatial scale too. So here are some of the results which we have seen that, in healthcare. So we have been able to do early detection. So some of the things which we were able to find is that this is the day zero when the actual symptom and actual testing happened. but we were able to detect that this person is falling sick about 2 days before the actual symptoms showed up, and that helped us prevent the contagion to spread. And so it gave us about $2,100 to $4,200 per case. And so here, people started to we get a much higher participation rate. So here, what we are doing is we are using Fitbit data. And through Fitbit, through passive data collection, we are able to detect complex situations 2 days in advance. So here, what we did was individual level agent. So the individual agent essentially detected the anomaly on your personal device. And then and everyone in the system generated a shared reality. And then so the multi-agent probability was activated based on superposition. LLM measured, and essentially the system determined that there is a pandemic uh, which is starting. And so here, there's a lot of real value to this, like the privacy. So individual data resides on the device and never leaves that. The scale is polynomial complexity. It scales very easily, and adoption. So, it learns from the outcome. Then we also have an implementation on workforce planning. And so this is beyond prototype. So here the challenge was that operations think in seconds, strategies plan in months, and each department speaks different language. And so through our Society of Agents solutions, so we could do temporal interpretation, interpolation, LLM semantic translation, and emergent workflow discoveries. So where there were thousands of locations where the decisions were made, and through society of simulation and shared reality, we were able to improve coordination efficiency by over 57% and decision quality from you know no 23%, and the latency of deployment came down from 4.2 hours to 1.8 hours. So there's a dramatic reduction and in quality as well as uh, performance. So here, why most of the agentic AI fail in production. So the problem is with governance. So LLMs hallucinate. So there's a typical 8.3% rate of hallucination. And then there is no audit trails and cannot explain any decisions. So our solution is multi-layer validation, immutable audit logs, human in the loop, and we reduce the hallucination to 1.2%, 97% compliance, and 3.2 times, ROI was achieved. So, so here are some of the risk and mitigation strategies. So LLM hallucination. So you need multi-layer validation, coordination failure, privacy breach. So here what we do is on-device processing, scalability bottleneck. So here our complexity has been reduced dramatically from exponential to linear. And adoption resistance, so users don't trust it, so making explainable decisions. So using XAI along with this, it increases the confidence. And the compliance gap, so that is where, especially in healthcare, where you can have audit trails and policies. So green light, you have to have a clear coordination problem, multiple autonomous systems, and high privacy requirements. Yellow light is single domain coordination, weak data infrastructure, and red light, no business problem and no governance. You don't try that. So our recommendation is you start small, 5 to 10 agents, single use case, 3 months timeline, and then scale smart. Measure at every step, build governance first, prove ROI early. Some of the things which worked, gradual rollout. So from 5 to 50 agents in 6 months. Human oversight started with 100%, now only 18%. The domain focus, we have healthcare and then workforce. And our approach is privacy first, where we have 89% participation versus 30% participation. Quick wins, ROI in 90 days. What didn't work? Full deployment failed. Black box, zero trust did not work. Tech first, no business case did not work. Replace legacy did not work. Integration did win. So 90 days, demonstrate value, 6 months, pilot to production, and governance uh, uh, before agents. So the verdict is agentic AI is a force only if there's a real coordination problem. You build governance infrastructure first, you start small, scale smartly. And Society of Agent framework, it is proven, production ready, and profitable. I end I'm just putting this plug in. My book is coming out on December 15th. So it is Dharma of AI. So this is timeless wisdom for digital ethics. You'll find a lot of very interesting use cases and insights into how to deal with digital ethics problems and what role you can play. So I will stop here and take questions.
Great. Here's a question from the audience. What
Mhm.
types of business functions or workflows are proving to be the best early use cases for agentic AI?
So what I have found is that whenever you have variety of models that has to be worked on. So, every model, as I said, they have different semantics. So let's say, you have workflow, force, you have production, you have finance. So in any of these cases, so if you design a core problem, then you can start building agents for each of these functions and first figure out how to integrate that. And so that is where Society of Agents, our semantics based model really works, because what we are able to do is focus on semantics, that what aspects of finance and operations and workforce they work together, and then marketing and production planning. So all these business functions. So you can create an agent and then let the agent coordinate, um, not through some fixed workflows, but through semantic generations of needs. And it works really, really well. So once you figure out the coordination aspect, scaling becomes very easy.
Great. Here's another question. What safeguards or oversight mechanisms are proving most effective in keeping these systems aligned with business and ethical goals?
Mhm. So now you are in my realm. See, see, the guardrails are important, but not externally. I mean, I'm not a big fan of what most of our AIs are doing, and especially like constitution layer or different rewards model, because these are bolt on after the fact. But if you define for each agent what are their roles and responsibilities, and I mean, essentially designing them for fairness and ethical consideration. So make them native. So those are the things which the agents evaluate first. And so now the guardrails, which will be that you don't want the agents to generate solutions which are uh, uh, you know, not ethically valid. To give you an example, so it was very early days of data mining and others. So I had a project with Department of Defense, and so we were doing some text mining, and so this was pre-LLM days. So we were taking, so it was really a multimodal data. So we were looking at different technologies and capabilities, and also the cost structure. So independently, they are unclassified, but we had absolutely no clue. So the program manager asked us to combine them, and when we combined them, then the moment they saw it, they said we cannot do that anymore because it becomes classified. So those are the things which will happen. And so that is why we are using quantum inspired, because then we can assign different states which are not to be pursued. And so all the and responsibility, ethics and fairness, they become native to the design process. And then it solves a lot of problems in the future.
Great. Well, thank you, Alok, for such an incredible keynote. And I also want to thank everybody else for joining us today. This session, along with all of today's content, will be available on demand following the event. This officially concludes the Argyle AI Decision Maker Summit, Revolutionizing Business Strategy with AI. Thank you again for joining us today and engaging in our content. We look forward to seeing you at our next Argyle Digital Information Technology event soon, which will be our CIO Leadership Forum, Navigating the Next Era of IT Innovation, on December 16th, 2025. Have a great rest of your day.
So thank you, and thank you everybody for your time.